So it's time to talk about flavors of thread. So I've already alluded to this. So I'm going to call this thread flavors. And what I'm talking about is basically two types of threads. You can have user threads, or you can have kernel threads. So I want to talk about user threads first. So when you create a user thread, the code that's executing the management of that thread sits above the operating system kernel. So basically, anyone can write code to implement a user-based thread. So you might have, for example, actually Java is a really good example of that. Java implements user-based threads. So when you make a call to create a thread, that call is a user level call, not an OS call. So what do I mean by that? It's going to trigger a library that somebody wrote that is not part of the operating system. Okay? Now, when it's time to run that thread, the operating system is not going to manage the execution of the thread either. So the scheduling of that thread to run is done in the user space. Okay. And there's advantages and disadvantages to this. So the advantage to this approach is that it's really fast because there's no OS overhead. It's um, portable. In other words, if you have user threads in your system and you write code that invokes some kind of API, that API is going to work on lots of different operating systems. So Java is a great example of this. In Java, when you create threads, okay, Java works on Windows, it works on OS 10, it works on Linux. So the thread management that Java has is done at the user level. The disadvantages are that you're going to lose the great OS management of threads, which may be closer to the hardware, which may give you better performance. All right. So I'll give you an example. In Java, the mapping of a thread, a user level thread that you create to any kind of concurrency is unclear. And so we're going to talk about that mapping in a second, but it's really unclear. Like if you create a Java thread, does Java figure out a way underneath the covers in the JVM to link that Java created thread to an actual operating system level thread? Because if it does, then you're going to get really good concurrency. If it doesn't, then you're not going to get really good concurrency. So there was a point in the past when I was working for a company and we were writing heavily multi-threaded code. And my job was I was in charge of the performance of the system. And the developers were saying, you know, on a lightly loaded system, things seemed to run really well, but on a heavy loaded system, things weren't running that great, and they didn't understand why. So I did some analysis, and what I found is as the system got more and more loaded, so as the request for the number of Java threads rose because of the concurrency of lots of users hitting the system, you would have expected to see a corresponding rise in CPU utilization, but that was not happening. The CPU utilization was really flat, and I was super puzzled by this. But after some research and working with a really great system administrator, what we discovered is that the Java thread library was using something called green threads. And what that meant was it had been written with the assumption that there was no operating system level threading available to the JVM. And so in effect, when you called to create a thread, it didn't really create a thread. What it did is it created it didn't create a true thread. What it did is it created that's the best way to say it is it created, well, let me see if I can explain this with a picture. I think that would be better. So when you created two threads, well, let's start out. So initially we have one thread of execution. This is our main program. Okay. Now, when you asked for, and this represents a level of concurrency. All right, you have one thread running, and this box here now represents a level of concurrency. Now, if you went to create a second thread, the expectation is that these two threads would operate independently, and we'd have sort of two different boxes which represent two sets of concurrency. So we'd have both threads running at the same time. But in reality, that's not what happened. What happened was there were two threads that were created. Java acknowledged that they were created, but there was only one box that contained concurrency. So in effect, only one of these threads could run at a time. So we really didn't have true concurrency, which was insane. So what we did is we went out and we found another JVM that actually took Java requested threads and connected those to operating system threads. All right. So that's user threads. The other type of thread is a kernel thread. So if you have an API that allows you access to a kernel thread, you have direct OS support for your threads. And you're going to see every kernel level thread that you request, you're going to get concurrency with that kernel level thread. So thread create calls are going to yield our OS calls. So you're going to get true concurrency. And typically those threads that you request are going to be mapped to multiprocessors. So maybe one thread per processor, or multi-core, maybe one thread per core support. All right, so Linux pthreads, I would say, are sort of quasi-kernel threads, right? There is this, right? They're not, like I said earlier, they're not really truly threads, they're processes, but they're a special kind of lightweight process that is created fairly quickly. And once you have a process that's managed by the operating system, you're going to get support for multiprocessor and multi-core, because the operating system will try to map processes across multiple processors and cores so that you can get a good degree of concurrency. All right. One other thing that you should be aware of is something called a hybrid thread. And these are not quite user threads and they're not quite kernel threads. So hybrid threads are basically user threads that are mapped to kernel threads. All right, and you can have a couple of mappings. So you can have a many to one mapping. This is essentially a green thread system. So this is the user thread, and this is the kernel thread. So many user threads get mapped to one kernel thread. All right, you can have one-to-one mapping, and this is effectively a kernel thread approach, right? Because every user level thread you create is going to get mapped directly to a kernel thread. And then finally, you can have many to many. And this is actually the Java approach. So for every Java user thread that gets created, that Java thread will get mapped to a kernel thread. But the thing is, if you create another Java thread, it may be mapped to the same kernel thread. So what you end up being is you end up being in a mysterious situation with concurrency because you don't really know how many of the Java threads you've created have been mapped to kernel threads, right? I could create three Java threads, which are basically user threads, and the JVM will map all three of those to the same kernel thread. Or I could create three Java level threads and the JVM will map each one to a separate kernel thread. I don't really know what that mapping is. So as someone that's very interested in software performance, that kind of thing is sort of a nightmare. But the Java folks would argue that this is a really good way of not overburdening the operating system with a one-to-one mapping between kernel threads and Java threads. All right.